So, working on this compressor VFD, the compressor was running at full speed yesterday. Then all of a sudden I heard a very loud bang, and yeah, you can see what happened. It blew L1 and L3 fuses, and it was loud. So now what I'm doing is I'm going to be doing a component test, testing the SCRs, possibly the IGBTs, and maybe even the DC bus. I have a step-by-step, which I will try to take you along for that journey in case anyone ever runs into something of this nature. You have some information to go off of. But step one was remove the line voltage and load. This is motor side, line voltage side, which you can obviously see. And that was step one, is to get those off. I could have taken like each individual wire off, but I just took the whole thing. It fits right here on these studs. So I figured that was even easier. They give you torque values, the whole nine. It's pretty nice, but yeah, that's step one. Take your leads off. Obviously make sure your drive is powered down and the voltage is low enough to where you're not going to blast yourself, because if some of you know, some of you may not know, I mean, on a 480 or 460 volt, 480 volt unit, you could have upwards of 700 volts on the DC bus where the capacitors are, and that'll be a bad day. So step one, I'll try to bring you back for step two and for along the rest of the journey. Okay, first step is to put your meter on diode. You put your red positive lead right here. That is a DC plus. And then you have a DC minus. Those are your test ports. So red positive lead, diode, black lead. Since my fuses are blown, I'm obviously not going to test down here. You put your black lead on L1, L2, L3, and you read your voltage. This should go to OL once it has charged it up. It's basically, it capacitively charges it. It charges the wire and the circuit and till it basically can't hold anymore, and then we see what happens. So right now, what I'm doing is I'm charging. I'm on L3. I've tested L1 and L2. I wrote down my results. And that, when you see is testing it, boom, then it goes to OL. So that concludes the DC plus with the red lead, black L1, L2, L3, and you are looking for OL basically. Now the next step is to leave the red lead in the DC plus, take the black lead and go to UVW, which is the motor, right? So I disconnect. And I since all this is connected, I just grab it. Oh well. So that's U, V, W. So that concludes that test. And now I will be switching these around. The black will go into DC positive, and then I'm going to take the red and then go through L1, L2, L3, U, V, W. That is the next step. So now it's red meter lead to DC minus, black meter lead to L1, L2, L3, UVW. Okay, so now meter black lead is on DC minus. Red lead goes to L1, L2, L3, UVW. So if you're doing a diode check and you see this, you can see how the voltage is going up. It means, as I said before, it's capacitively charging it. So you just got to give it some time. You got to have some patience in this game. So this should eventually go up to, which 3 volts is the max output of this meter. It should go to 3 volts and then realistically go to OL. So we're gonna let it try and do that, but you just got to have some patience. And again, black meter lead is on DC minus, and I am now on U, which this is the motor side. Obviously, you got line side, load side, which is UVW. Same thing as L1, L2, L3, but they're motor terminal designations. At least that's how we use them. I believe Europe is slightly different. I think they use UVW on line and load. Could be wrong. Somebody knows, they can correct me if I said it incorrectly. But yeah, you can see we're charging it up. And if it doesn't go to OL, now that's a problem. My guess is it will, but we shall see. These are my results from taking the different checks.